Motion diagrams, easy to make and read, but not so good if we've got to do math. They're not real useful when it comes to problem solving because you can't really do math with them, but they are useful in just representing motion. So we're going to just breeze through this pretty quickly. Motion diagram is a number line with dots next to it. Each dot represents where the object is at a certain time. The dots are drawn at regular times, so 1, 2, 3 seconds, 5, 10, 15 seconds, whatever you're dealing with. We can change a position and timetable into a motion diagram if the table has equally spaced times. Don't know what I'm talking about? Well, here it is. So the red car on top is going slow, but the green one is going faster. Every second that goes by, each one is dropping a dot at where it is. The green dots are spread further apart because the green dot is going faster. It's covering more distance in the same amount of time, while the red one has dots that are closer together. And all of this is taken from a position time table, like we were working with in the previous videos. But here, the blue car is speeding up. The dots start close together because it's going slow in the beginning, so it's not covering as much distance in the same amount of time as it is in the end. Now, by the time it gets towards the end, the dots are further spaced apart because it's covering more ground in the same amount of time. Purple car on the bottom is doing the opposite. It's slowing down, so the dots start off spaced really far, and then as it gets closer towards that 100-meter mark, the dots are a lot closer together because it's covering a smaller distance in the same amount of time. The red motion is on top. Is that moving object going left or right? Tough to say, right? The green motion diagram on the bottom, is that object moving right and speeding up, or is it moving left and slowing down? We can't really tell, so we need to make it apparent. We will usually draw arrows on each dot to represent the direction the object is traveling at that dot. The arrows become longer as the object's speed increases. We would say that the arrow represents the magnitude of the velocity. And however long that arrow is, that is representative of your magnitude. So the longer the arrow, the greater the magnitude. The direction the arrow is pointing tells you the direction the velocity is going. That's your direction. So just by this one little arrow, you're able to give magnitude and direction for your velocity to represent a vector. Here, the green car travels at a constant speed, so the arrows are the same length. The blue car is speeding up, so it starts with a shorter arrow and then gradually gets longer and longer and longer. The purple car slows down, so its arrows are getting smaller and smaller and smaller, and the purple one is going to the left rather than to the right. If an object changes direction, the dots will drop down the same way that we drop down to the next line when we read on a page. If an object stops, then the dots drop down each second that the object is stopped. This car slows down for 5 seconds, stops for 5 seconds, and now we're speeding back up for 5 seconds. To calculate average velocity, get the displacement between the beginning and the end of the motion. Here it's 5.8 minus 0.3 gives us 5.5 meters, and the time interval is from 0 to 1.2 seconds. Divide displacement by time, and we get 4.58 meters per second. To calculate instantaneous velocity, let's say at exactly 1 second, we would get the displacement between the dot before and the dot after. So this one to this one. And that's going to give us 1.7 meters. Divide that by our time interval before and after, which is 0.2 seconds, to get the average velocity of 8.5 meters per second. The advantage here, it's easier to see if the object is speeding up or slowing down, just by looking at the proximity of each dot to the next one. The disadvantage, we still really don't know for sure what's happening in between the dots. We can just kind of fill it in with what we expect would be happening.